Oh, I can do that now. Okay, so there's no problem. All right, so number 73. Let me know if there's a problem, okay? So 3x plus 1 to the 6, and this is 1/2, and times 2x minus 5 to the negative 1/2. And this is 2 plus 2x minus 5 to the 1/2, and the 6. Here is a 3x plus 1 to the 5 and the 3. What is the goal? The goal is to get in the factored form. Okay. Factored form including this. Can you all hear me right now?
Yeah.
Okay. So the factored form is like this. It's so like a plus ax plus b, cx plus d. And the bottom is x squared plus 1, a squared, c squared plus x minus 5. So this is called the factored form. It's in the quotient form, in the product form. Okay, so we don't want to have the, in the end, it's still like a sum of the fractions. That's not the way to simplify. You understand? Your goal is to write this sum, complicated sum, as a product or quotient for all the factors. You are not allowed to have a fraction over fraction here, like a 3, like x squared minus 9 over 16 over x plus 1 times 3/2 and x plus 2 to the 1/2. This is not allowed because there's a fraction there. Do you understand?
Yes.
Okay, so this is not allowed. Okay, it's not, you are not allowed to have fraction over fraction because it's not simplified. Okay, so that's the goal. Okay, fraction is, you know, a over b is considered to be a factored form. So like or a over b form, quotient form. So these are the ones you like. Okay. So to do that, obviously you need to see the common factors. You can see that here. Give me 1 second. Right. Here you can see you have 3x plus 1 to the 5th. This is 3x to the 6th, right? 3x plus 1 to the 6th. So you should factor 3x plus 1 to the 5th out. You agree?
Yeah.
And inside here, you get 3x plus 1. The 1/2 and 2 canceled. So you should clear this out right away. And then here, you get 18 times what? 2x minus 5 to the 1/2. Do you agree?
Yes.
Now, what do we do from here? Well, you see a negative power, yes? So let's factor the negative power out, okay? So if you factor the negative power out, so that's going to be 3x plus 1 here, yes? Plus, what do we have on this, the other factors? So factor this out amounts to multiply 2x minus 5 to the 1/2 here. And you also have to do the
Denominator.
Yeah, you have to do the same thing in the denominator. Do you agree?
Yes.
Because if you cannot multiply a number only on the numerator without doing the same thing on the denominator. Otherwise, you would change the fraction. Yes? Like this, 1 over root 2. How do you rationalize the denominator?
Multiply by root 2 over
Yeah,
root
you have to multiply the top and the bottom by the same, right? So you need to multiply here and here. So this one is 2 to the 1/2. This is 2 to the 1/2, right? So when you see this one is 2 to the negative 1/2. So when you see the negative power, you multiply the top and the bottom by the same positive power. You agree? Riti, do you understand this?
Yes.
You do. Okay. Vishwa, do you understand this?
Yep.
Okay. I want to go over every single one, okay, to see if you really understand. Oliver, do you understand this?
Yes.
You understand this one? Why I did this, right?
Yes.
Let's see who else is here. Eric, do you understand this part?
Yes.
You do understand now. Okay. Let's see. Who else is here? Adi. Do you understand this part? Adi? Or Adit?
Yes.
Okay. Does anyone still have trouble on this part? Anyone? No one, right?
No.
Okay, very good. So you see, whenever you see the negative power in the sum of that means you have a fraction plus a fraction. So what you do is you multiply the same you multiply the corresponding positive powers to the top and the bottom. This amounts to factoring the 2x minus 5 to the negative 1/2 out. Okay, so let me say this. Let me do this. So if you multiply this top and the bottom, then you see, let's multiply the, so this guy stays in the denominator. A lot of people just did what? Just threw away the denominator. You cannot. So you have the 2x minus 5 to the 1/2 as the denominator now. Now, if you multiply this guy to the first summand here, what do we get? Tell me. You just get 3x plus 1, do you agree?
Yes.
Because 2x minus 5 to the negative 1/2 times 2x minus 5 to the 1/2, they cancel out, which is 1, okay? Now you have to do this to the second summand. So it's going to be 18 times 2x minus 5 to the
First
how many
power.
power? First power, do you agree? And I do see about 5 students in this class who did these problems have no trouble, without any problem. But I seen at least another 5 students having a lot of trouble here. Don't know what to do with each of these steps. Okay. So we simplify the inside. You don't leave this here. You have to simplify the inside. You get 36 plus 3 is 39x. And negative 90, so it's going to be negative 89. Okay. Divided by 2x minus 5 to the 1/2. I think the internet is lagging again. Is that right? Or is it okay right now?
It's
okay
it's
right now.
okay.
Okay.
It's okay right now.
All right. So number 73, that's how you do it. Okay. Does it make sense to you now? You see, in the end, it's in the factored form, right? This is a factor, this is a factor, this is a factor, right? So this is in the factored form. A times B over C, whatever the power is. So that's the one which we want. Remember that this course is a pre-calculus. Pre-calculus means what? Everything we do here is serving for the purpose of calculus, okay? Let's do 79. So this one is x squared plus 4. And then to the 1/3 and times 3 minus 3x. And then the 1/3 here. So this is x squared plus 4 to the negative 2/3. And then you also get 2x here. The denominator is x squared plus 4 to the 1/2, then squared. Do you know how they make up this kind of a problem? Do you know, Edward? Any idea how they made this problem? Probably no idea, right?
No.
It is a calculation of the derivative in calculus. So that's how they do it, all right? So, and they differentiated a complicated function, then they end up with this. And then you need to simplify it. That's all they did. They don't make up the problem just by thinking, okay, weird. No. All right, so in this case, did you see that 1/3 and 3 are canceled? Yes? So
Yeah.
since they're canceled, we don't have to what? Treat this as a negative power anymore, right? So 3 and 3 can 3 and 1/3 cancel. Now here is the only negative power, do you agree? What should I do? How do I simplify this? I need to multiply top and bottom by
Positive power.
x squared plus 4 to the
2/3.
2/3. Everybody's with me, right?
Yeah.
Yes.
All right. So then, so don't forget, this is a difference, okay? This part is a difference. So when you multiply a minus b, then you multiply c here. How do you multiply it? You have to multiply a with c, then minus b with c here. Do you agree? It's distributed. Yes? So
Yeah.
what we do here is multiply this guy into this, and you also have to multiply it into this factor. Okay. If you multiply this to the first summand, what do we get? 3 is a constant. Then you have x squared plus 4 to the 1/3. Then x squared plus 4 to the 2/3. What do we have then?
X squared plus 4.
That's it. You agree? And now don't forget the 3 and the 1/3 canceled. So you get minus 2x squared, yes? What about this guy? This times this is what?
One.
Just 1, okay?
1.
And therefore you get just 2x squared on the top. The bottom is x squared plus 4 here. But you also have another 2/3. So adding up is a 5/3, do you agree? And simplify the top and the bottom, you get x squared plus 12. And I do see several students get super good on this set, okay? So essentially they have no errors in the entire assignment. Do you know what that means? So there's no error, not a single error in the entire assignment. And that's really, that means they do review the lecture. They do understand every bit of my lecture, all right? They did their homework very carefully. I really like to see this, okay? I really want to see everybody in my class can do the homework perfect, okay? Now, number 82. Actually, I also did the number 81, right? I also assigned number 81, did I?
No.
No.
Okay. Did I assign 82 then?
Yes.
I did. Okay, so
Yeah.
let's do 81, 82. Okay. Now for number 82, we do this because this section becomes a difficulty for a lot of students. So that's why we have to be patiently going forward. So this is 2x plus 3 to the negative 2/3 and times 2 minus 2x plus 3 to the 1/3 and 1/2 and 3x plus 2 to the negative 1/2, then 3, okay? Divided by 3x plus 2 to the 1/2, then squared. Now, how do I do this? So this time you're going to help me on this, okay? How many negative power you see here?
2.
2? Which 2?
2x plus 3 to the negative 2/3 and 3x plus 2 to the negative 1/2.
So if I see the negative power here, then what would I do?
Then multiply it by 2x plus 3 to the 2/3 power. And we need to
And?
multiply the other one by 3x plus 2 to the 1/2 power.
But I think you missed 2 negative powers, 2 more. William, this one is a negative power, do you agree?
2 to the, yeah, times 2 to the 1.
We also need to
So it's a-
multiply.
yeah, you should multiply a 6 here, do we?
And
Yeah.
also need to times 3 to the 1.
Yes, this is 6.
Yeah. And then we also need to include it for the denominator too.
Right, so you don't throw away the denominator. This is what the people do. They did everything in the numerator, they threw away the denominator entirely. Well, if you throw away the denominator, do you know how to add fractions? My question is, right? You cannot, it's like this. X here. So this is h. You know what the people do? Okay, let's put a 1 there, just a 1, okay? They get x minus plus h over h. Is this correct? Is this correct? Hello?
No.
Oh,
What's wrong?
forgot to multiply the denominator.
Yeah, so this one, you see, when you combine these two fractions, you have a common denominator, which is x times x plus h. Do you agree? And you do the same here. Agree? And so if you cannot throw away the denominator. Agree? The reason I bring this up is because this is a commonly made errors in the high school algebras. Okay, people always forget the denominator completely. Okay. All right, so this is the situation we have. Now, after I done that, you know that your goal is to what? Multiply these common factors into each of these summand, okay? First of all, let's keep the denominator. So what's the common denominator there? 3x plus 2 to the how many power?
First power.
Yeah, this is the first power, but you also have a 1/2. So it's gonna be
3/2 power.
You also have a 6 here. You also have a 2x plus 3 to the 2/3. Okay. Make sense?
Yeah.
Yes.
Riti, do you follow me? Riti, can you tell me, when I multiply this thing here to the first summand, tell me what I get.
Okay. You get 3x plus 2 times 2 times 2.
It's gonna be 4 here, right?
Yes.
Yes. Okay, minus
Minus 2x plus 3 times 3 times 3, so 9.
very good. Now you are there. Is this very hard?
No.
No. You see? Now we completely feel comfortable about it. Don't you agree? All right. So now we have what? We have a total of 12 minus 18, so negative 6x. 8 minus 27 is a negative 19. Agree? And this is the simplification. Okay, so do you guys know this? I taught the college students like many years, okay? So many years. You know what's the biggest failure they encounter, okay? They cannot learn calculus, most of the students. You know why? It's not because they are, the brain is not smart enough, all right? They cannot do calculus because calculus is too hard. It's not because calculus is too hard. It's all because, can you guess some reasons? William, can you guess a reason that why they cannot learn calculus?
Because they can't simplify these expressions.
Yeah, they all fail on chapter 1, okay, and chapter 2. So college students cannot do well in calculus because since they never learned chapter 1 and chapter 2 well. It's just these two chapters. That's why we have to be very slow.
I think it's lagging a bit.
Say it again?
I think it was lagging a little bit.
It's a little bit, okay. So, well, you just have to tolerate it today. I don't know what happened to this. I have to figure this out, okay. All right, so this is number 82. Maybe we should do one more example. It's about simplifying this, you know, let's see what I want to simplify here. Other things are okay now. I don't think I want to do more. Okay, so, oh, there's a number 51. Okay, number 51 is the one which I need to do. So it's 81 x squared minus 16 y squared over 3 times square root of x minus 2 times square root of y. And people don't know what to do with this. So in this case, the question is to rationalize the denominator, right? How do I rationalize the denominator? Tell me.
Multiply by 3 square root of x plus 2 square
Right.
plus 2 square root of y.
Okay, so then the denominator becomes a squared minus
9x minus 4y.
and so you want to simplify this, right? So what is this guy in terms of, you see the different square there, right? It's going to be 9x minus.
I think it's lagging.
Yeah. So there's nothing I can do right now. Are you with me?
Yeah.
Okay. Now the point is what? These two cancel. And this is 3x plus 2 root y. Make sense?
Yeah.
So this is how you simplify it. And some people don't know what to do, have no idea what to do. But you didn't read the instruction, right? The instruction asks you to rationalize the denominator. So you need to rationalize the denominator to see what to do next, right? So once you see the 9x minus 4y in the denominator, then the numerator obviously tells you should factor that out, okay? All right, so we're done with section 1.4. We're gonna have another assignment on that, okay? And today we're gonna do section 2.1. So section 2.1 is about solving equations. Now, so far, in chapter 1, we don't have any equations involved, right? So here's an example about the equations. So how do I solve 2x minus 1 equal to 3 minus 7x? How do I solve this equation? This you learned in Algebra 1, don't you agree? Yes? Okay, tell me what do I do?
Yeah.
What do I do?
So we need to isolate the x variable first.
So you can add the same number to both sides, you agree?
Yes.
That's the rule, right? So add the same number to both sides of a equation. It doesn't change the solution, right? So does not change the solution, yes? So that's the point. Okay, we can add 7x to both sides and add 1 to both sides, right? So basically we add 7x and then plus 1 to both sides. Do you agree? Yes? If you add 7x and add 1 to both sides, you get a 9x on this side, then you get what? you get 4 on the other side, yes? So basically move the 1 to this side, you move the next 7 to the other side. Are you with me?
Yes.
Yeah.
Yeah.
Yeah. Yeah.
So now you know how to solve this, right? Which is x equal to 4/9, yes? That's how you solve it. Okay, so let's try one more. 2x minus 1 quantity, let's do this. Yeah, let's just do this. 2x minus 1 times 6x plus 4, right? And then equal to 3x plus 1 times 4x minus 2. How do I solve this equation? So complicated.
Multiply the quantities on both sides. So multiply 2x minus 1 and 6x plus 4, and then multiply 3x plus 1 and 4x minus 2.
Right.
And then and then you can subtract 12x squared from each
Right.
side.
Yeah.
Yeah.
So the whole point is that both sides have the same square term. So you get 12x squared. Negative x plus 8 is going to be positive 2x minus 4. The other side is 12x squared. Negative 6x plus 4 is negative 2x minus 2, okay? Now you see the point is that we can cancel the square term out. Then you get 4x equal to 2. So x equal to 1/2. You agree?
Yeah.
That's how I solve it. Very good. How about this example then? So let's do 3x over x minus 2 and equal to 1 plus 6 over x minus 2.
Multiply both sides with x minus 2.
Right. Yeah. So let's do that. If you do that, you get what? You multiply this to this side, you get what? 3x. When you multiply this to this side, you have to multiply to both terms, yes?
Yeah.
So you get x minus 2 plus 6. You agree?
Yes.
You get 2x equal to 4. X equal to what?
1/2.
Are we done? Are we done with this?
No, because if you plug that into the first equation, then the denominator would be 0.
Right. So you see that we are not solving other equations. We are solving the original equation. So you have to check, right? You need to check. When the original equation has a denominator, because the denominator cannot be 0, you have to check. Check that x cannot be equal to 2, right? So therefore, how many solutions we have then?
Most of them.
Right. So Edward, can you tell me, I did all my algebra right. Why? This is what we solved by all my algebras there, right? Why do I get no solution then? It looks like my solution is correct, right? What happened?
Because
There's some extraneous solutions.
Could you say it again, William?
There's some extraneous solutions that don't work.
Well, you have to tell me why I got this extra. Did you agree that I did my algebra right?
yeah, but x minus 2 can't equal 0.
Right. Very good. Very good. Yeah. So you can teach for me, Edward. Very good. Yeah. So the point is this: when you try to, is 1 equal to -1?
No.
But if you multiply 0, you see what happens. Both sides. They do equal. Yes. So in other words, if you multiply common things to both sides, the common thing cannot be equal to
0.
0. You cannot multiply 0 to both sides of the equation. Okay. So the point is this: the reason, okay, we get this extraneous solution. This is called the extraneous solution. Is because we could multiply 0 to both sides, right? We could multiply, I shouldn't say we could have multiplied, right? So multiplied 0 to both sides. If x equal to 2, right? So in other words, if you if you really want to do your algebra right, you have to assume at the beginning that x cannot be equal to what? You have to assume that x cannot be equal to 2 there. Yeah. If x equal to 2, you cannot do the first step. So your algebra is wrong. If the algebra is wrong, if you do not assume x is not equal to 2. Okay? And that's the reason. All right. Okay, so in the future, you should know that whenever what? Whenever you solve equations involved with a fraction, you have to what? You have to?
Check the denominator isn't 0.
Yeah, you have to check the denominator is non-zero, okay? Maybe we should do one more example. Just want to make sure that everybody really get this point. Okay, give me 1 second. I need one more example here. So, right. So this is a problem. Let's try to solve. Is number 36 from the textbook. Well, actually, I want to do something a little bit more complicated. Let me see. Right. Let me do number 42. Okay. So number 42 from the textbook. So that's a 3 over 2x plus 5. And this is a 4 over 2x minus 5 equal to 14x plus 3 over 4x squared minus 5, yes, 25. Now, how do I solve this equation then? Anyone?
Apply 4x squared minus 25 to both sides, since 2x plus 5 times 2x minus 5 both equal to
Yes.
4x minus 25.
Very good, very good. So the common denominator is what? 2x plus 5 times 2x minus 5. Then look at this. Because this one can be factored as 2x plus 5 times 2x minus 5. Do you agree? So we should multiply 2x plus 5 times 2x minus 5 to both sides. If you do that, then what? What's the left-hand side? So you get 3 times, tell me.
2x minus 5.
2x minus 5. Plus 4 times.
4x plus 5.
And the other side equal to?
14x plus 3.
Very good. Very, very good. Okay, we simplify this. So you get 6x plus 8x is 14x. Do you agree?
14x plus 7 equals 14x plus 3. So there's
20
no
minus 15 is 5, yes. So what happens then? You get 2 equal to 0, right? Or 5 equal to 3. What does that mean then?
no solution.
So this one is just happen to be no solution. But sometimes if you change the number a little bit, okay, if you change the number a little bit, for example, instead of a 14 plus 3 here, I could have a 14 33. Okay. So let's say, suppose this is 14 plus 33. Then what happens? Oh, I'm sorry. Sorry. I mean that this will be 13. Sorry. Let's see. So I want to do this. I want to do 12x then plus Just 12x, that's good enough, okay? So if I have a 12x, then this side is 12x, do you agree? Yes?
Yes.
And then what do we get?
The solution is -5/2, but that would make the denominator of 3/2x plus 5 0. So it's
Right.
still no
So-
solution.
Yeah, so you see, in this case, you could also make a x equal to -5/2, but you cannot stop here. You have to what? Check.
Solution.
Denominator.
And when you check, you see that that would make the denominator equal to 0. So there's no solution, okay? So I changed the problem, okay, a little bit. So that the question becomes interesting, yes? All right, so this is the equations involved with fractions. Okay. Let me show you another one, which does have a solution. This is example 4, which is 3/2x minus 4 plus or minus 5/x plus 3 equal to and 2/x minus 2. So what should I do?
Multiply by 2 times the quantity of x minus 2 times the quantity of x plus 3 because 2x minus 4 can be simplified to 2 times the quantity of x minus 2.
Right. So don't try to multiply everything together, okay? If you multiply all of them, then you're making things too complicated. The thing is, every single time you should see if your denominator can be factored or not. So this is a 2 times x minus 2. And this implies the common denominator is 2 times x minus 2 times x plus 3. Do you all see this?
Yeah.
Yeah.
Okay, very good. All right, so once we have that, you see what happens? If you multiply this guy to the first fraction, you get
3 times x plus 3.
right. So 3 times x plus 3 minus multiply this to the second, you get
5 times 2x minus 4. I mean,
well, there's
negative.
another 2. There's a 2 here. So it's a 10, right? Oh, I see. That's the same. Yeah, you are saying that 5 times 2x minus 4, right?
Yeah.
And that's fine. That's fine. So we cancel the x plus 3 out. So it's a 10 times x minus 2. And that's equal to what? 2 times 2. So it's a 4 times x plus 3. Okay.
Yes.
Yes. Now you could expand it, but you should notice that this is 3x plus 3. This is 4x plus 3. You probably should do this way. Just 1x plus 3. Do you agree? It's a little quicker. And so therefore you get 17 equal to 11x. Now that tells you x equal to 17/11, right? Do you agree?
Yeah.
How do I check? How do I check the solution? Do I need to put the x? Do I need to put the x into this expression, into the original equation to check?
No, you can just check if any of the denominator expressions is
Right. When we check, all we check is what? Check the denominator is non-zero. Okay. So
Or-
check.
or check if there are square roots of negative numbers.
No, later. Okay. So check only for the denominator to be non-zero. Okay. So that's the only thing you need to check. Do you agree? You don't put this back into the original equation to check the equality there, because as long as the denominator is non-zero, as long as your steps are correct, okay, then you know that your solution is good. All right. You need to check your steps. This is the steps you need to check. You need to check to see if you made errors on your calculation. But in the end, you only check if the denominator is 0 or not. Make sense? Do we understand? Does it make sense to you?
Yeah.
Yes.
Yeah.
Very good. Now next is this. So far, you see, in the school, nobody makes error on this. You agree? What is square root of 2 squared?
2.
2. But people do make errors on this. Why?
Just write it as x when it's supposed to be absolute value of x.
Why they have the trouble here? Here's a number. Everybody has a very good, feeling about numbers, but they are not comfortable with what? The letters, okay? The letter representing a number, but the point is that the letter can be represent every single kind of number, not just positive numbers. Like this one, nobody make errors on this one. What is this guy?
2.
2. Nobody make error on this, but people do make error on here, right? Because it's all because the x could be representing any number. So the same thing happening here. So we are going to solve equations involved with letters. So we're going to see letter equations, okay? Here is examples. C equal to 5/9 of f minus 32. What is this equation representing?
The
Conversion from Fahrenheit to Celsius.
Fahrenheit to
Yeah,
Celsius.
you convert the Fahrenheit to Celsius, right? All right, so for this equation here, how do I solve f then? F is,
First,
First, multiply by 9/5,
right.
then add 32.
So f equal to what? First of all, it's a 9/5 of c. Then you add 32.
Plus 32.
You agree? That's how I solve it, right? So another example is this. If I have 1 over r equal to 1 over r1 plus 1 over r2, then can I solve for r2 here? We can, right? How do I solve for r2?
R2 equals the reciprocal of
Don't do that. So give me steps, okay? So I know you can do the answer, but how do I solve for r2 in general?
subtract 1 over R1 from each
Okay,
side.
you do that. So you do 1 over r2 equal to 1 over r minus 1 over r1, okay?
Then take the reciprocal.
Right, so it's gonna be, let's simplify this, combine this as a single fraction in order to take the reciprocal, all right? So let me do this. Since we are solving equations, we should put the equation equal to equation, okay? You're gonna 1 over r2 equal to r1 minus r over r1. That tells you r2 equal to what? The reciprocal of this thing here, okay?
Yeah.
Or you do this way, or you can multiply the both sides by the common denominator, r1 and r2, okay? You can do this, right? Get one? Can I
Yeah.
do it? Now, if you multiply this to the first term, you get what?
R1, R2.
R2. Right. So the other side is, if you multiply to the second term here,
R2
plus R1.
our goal is to solve for R2. So let's put R2 term together. So it's R1 minus R times R2 equal to R1, okay? That implies that
R2 equals R1 over R1 minus R.
Same, don't you agree? So there are two different ways to solve. You can use the common denominator method as we did earlier, or you can what? Or you can solve the isolate R2 terms, okay? Okay, so that's pretty much everything about this section, but let me do one more example. So suppose I have y equal to 3x minus 1 over 4 plus 2x. That's a solve x in y. How do I solve x in y? So x is in the denominator. You have to bring it up, right? How do I solve this?
Multiply 4 plus 2x to both sides.
Right, so you get 4y plus 2xy equal to
3x minus
3x minus 1. Very good. Our goal is to solve for x. What do I do?
the x terms.
Combine the x terms, right?
Mm-hmm.
We do this. Then we move the other term to the other side, agree? Are you with me on this, everybody?
Yes.
And then 4y plus 1 equals x times 3 minus 2y.
Very good, very good. So this is what we do. So we factor the x out from these two terms, right? So you get 4y plus 1 equal to x times 3 minus 2y. And you can see x equal to 4y plus 1, 3 minus 2y. You agree? Yes?
Yes.
And that's how we solve it. And that doesn't seem to be difficult. You agree? Okay, so in this section, the only subtle point here, okay, so the only subtle points is what? Is to check when solving fractional equation, right?
Check if the denominator isn't 0.
Right. So that's the thing. Okay. So that's the only subtle point in this section. Okay. Key point of this section here. You guys should make sure, right? So this happens all the time because people always forget it. But if you go to SAT, you solved everything right, and then in the end you just forgot to check. Do you know what happens? You lose one problem, right? Do you know what the one problem mean in percentage? You guys take SAT before? No one yet, right? So if you miss one problem, it's from 800 to what? 790. Lose one problem for math. And that go from 99% drop to what? Do you know?
95?
Just one problem. So because most people, these days people are getting better and better in math, so they don't make errors. Okay. So here was if you miss a tiny bit of it, like you forgot to check, that's what's going to happen to you. All right. So you don't want to make any error. Okay. So otherwise, don't think that okay, making a little error is not a problem. Okay. And that's the thing which I like to see. Edward, can you try to perfect your homework?
Okay.
Yeah, because your understanding, I haven't seen people that good yet. Okay, so I mean, at your age, I only see like 1 or 2 students in my past years of teaching here. So your understanding is great, but you have to take care of your accuracy. Okay, when you do the problems. Okay, so do it slowly. Don't try to rush, because the homework is the place where you improve, you make progress. Okay, understanding is one thing. You can always learn advanced material. I will teach you all the advanced material. But if you cannot do your calculation right, it's always going to stop you this and that. Okay, so it's absolutely becomes crucial for you. Okay, if you do your calculation right, every single time, you're going to be reached to the top. Okay, very quickly. Okay, but if you keep making errors, then you will see it's very frustrating that you every single time you're going to be stopped by little trivial or silly errors. Okay, take it serious. Okay, Edward, you understand my advice?
Yeah.
Okay, so do that. Okay, I want to see perfect paper. Okay, just double check. Okay, all right. So this is the section 2.1. And now we're going to go into section 2.2 about solving story problem. Okay. Now story problem right now it's all linear. It's very simple, not hard story problems. So let's just, but there's some basic principles to to solve story problems, and it's very easy to follow the principle. Okay, so you just understand how to set up a variable, then set up equation, then solve it, and then answer the question. So here's the first example. Suppose I have test scores 79, 82, and 91. I'm improving for test 1, 2, and 3. Okay. So wish to average to 85. Okay. Maybe 88. Okay. Get a B plus in the course. So in test 4. I mean,
Test.
after test 4. Okay. So after test 4. So the question is, what score I must have in test 4 to have such average, right? So what's the question? Ah, you guys are already there. Okay, so let's I know this is a simple problem to you. Okay, everybody knows that. Okay, so don't tell me. Okay, so you see, when you go through this course with me, you will see that the things you learned before will come back, but some of the places would haunt you, right? So the things which you took it for granted may not be true. Okay, so you need to be very careful about this. Okay. Now for this one, everybody knows how to solve. So the standard way to solve story problem is what? You need to have several steps. The first step is what?
Set
What
a
is this?
variable.
Yeah, you have to set x to be the
number you're trying to find.
right, test the 4 score. Okay, in this case. So that's the first one. And then use it to find a equation. Do we?
It's lagging.
Yeah, sorry. So let's see what happens to here. Okay, so is it better? No? Now,
Yeah.
so this is the equation. When we set up equation, what does that mean? Set up equation means what? You need to have the same quantity, but calculated in 2 different ways, agree?
Yeah.
What do we need? This is the average. What is this equation is about the average, do you agree? And on the one hand, I need the average to be equal to 88. How do I compute the average from the other? What is the other way to compute the average?
79 plus 82 plus 91 plus x over 4.
Right. So what I'm saying here is this. You need to use the word average. These averages are called mathematical, mathematical keywords, right? So this keyword says what? You need to know what is the average, how average is defined. It's just the adding all these scores divided by number of these scores, okay? And so this implies x equal to, so 362, right? 352, sorry. Agree? Minus what? Minus 79, minus 82, minus 91. Is that correct?
Yeah.
So we subtract that. So how do you subtract this? The way to do this probably should see is a better way. So this putting together give you
170.
70 to 52, right? And so therefore exactly 100. Yes. So
I know a quicker way to do it.
I know. that kind of a quicker way, you do it when you compete, when you do math counts, okay? Not here. For this course, we cared about the fundamentals, understanding of the math, okay? We don't care about how fast you do. So sometimes you do have a shorter way, but let's not worry too much about it, okay? All right, are we all comfortable with this? Yes?
Yeah.
So this is how I solve it. So this is the third step, you solve it. And the last step, there's one more step. What is the last step you're supposed to do?
Check.
Not for this problem, right? So this one, there's nothing you need to check. So you're supposed to answer the question because it's a story problem. When you try to solve the story problem, the x you set may not be the quantity you wanted. You understand? Sometimes you want to set x as intermediate quantity. So in the end, you have to refiguring out the final quantity. So answer is that we need 100 in test 4, okay? So you know the answering is important because sometimes your variable you set is not the final answer you want. Okay, we're gonna see that in a minute. Okay, does that make sense to you, everybody?
Yes.
This is important that the answering question is important because sometimes you may use a intermediate variable, okay, to solve the problem. But then in the end, you have to adjust it, okay? All right, so this is second example. The third example is this. Oh no, this is the first example. Second example is this. Now, a clothing store sells, sells all items with a discount. So discount, sorry, sells all items with a discount 20%. If a shirt, okay, is selling for $28, so what was the original price? I don't want you to give me answer, okay? I need you to follow the 4 steps I did. First of all, what do I do?
Define the
Variable is the original price.
Yep. So we let X be the
resale price.
yeah,
Or-
original price. Then
The equation is x times 100 minus
let's
20.
no, let's do this. Let's X minus
20% x.
yeah, right. That should be equal to what?
28.
28.
So follow the keyword here. Keyword says discount. Discount means what? You take that percentage off. You agree? That's the definition of discount. You agree? All right. So then this says 0.8 x equal to 28. That implies x equal to 35. Yes. Yes. So the answer is, so usually as we said, no matter what, try to answer the question, okay? The original price is $35. Okay. Now, if the store, okay, takes another 30% off of the new price, of the selling price, sale price, right? what is the total discount?
So first we let X be the total discount.
Okay, so we let X be the total discount, okay? So,
And X is equal to 100 minus 1 minus 30% times 1 minus 20%.
right, okay, so very good. So that's very good. So can we do a different way? This is a little bit too hard, okay, if you do this. So what you do is we let X be the original price, okay? Then what? Then the first sale price is what?
80% of X.
Yeah, is X minus X times 20% of that, which is 0.8X. Now apply the second discount. Okay. We get what? So this is new sale price, right? Then you have to
0.8.
subtract 0.8X, that's a new sale price, times
30%.
70%, right? That's the, after apply the second discount, we have this price, which is point what? I mean, this should be 30, right?
Yeah.
So that should be 0.7 times 0.8, then times X, do you agree? Which is 0.5.
0.56X.
So therefore, what is the total discount then?
1 minus 0.56, so it's 44%.
That's right, the total discount is 44%, agree? So I know that, you know, it's easy for some of you very quickly, but you should know that this is the, yeah, this is the answer you're supposed to follow, okay? All right, so this is the second step, okay? So we just combine several steps together. So this one is that you apply a new discount against the first discount, all right? Very good. The next class of problems is called the mixing chemicals, or maybe let's do example 3 about the simple interest first. Okay. A investment firm has $100,000 to invest for a client and decide to invest in 2 stocks, A and B. The expected annual rate of return for a simple interest for stock A is 15%, but there is some risk involved, and the client does not wish to invest more than $50,000 in this stock. The annual rate for return on the more stable stock B is anticipated to be 10%. 10%, and determine whether there is a way of investing the money so that the annual interest is 12,000 and 13,000. So you have $100,000 to invest, okay, into A and B.
And the problem.
Right? I'm sorry? This is example 3. Okay. Now, invest in this. We don't know how much to invest each, but we know that the A has a 15% interest rate. This is 10%, right? So there's a risk, but you want, so let's say we invest X into the first stock, then the rest will go to what? Go to B, do you agree? But you don't want X to be greater than 50,000. So you want this to be less than 50,000, okay? So this is the condition of the question. Do you guys see that?
Yeah.
So when you solve the problem, you should make a little chart here, reminding yourself what the question is about, okay? So obviously, you know, because you want to see how much to invest in each of these stock. So you say maybe we invest X into one stock A, right? Stock A, then the rest will go to stock B. Now, the total interest is $12,000. So you need to see how to compute this, right? So this implies that $12,000 should be equal to what? Should be equal to X is invested in stock A. That means X should multiply by 15%, okay? So the interest is this. No matter how much money you invested in this stock, you multiply the percentage of this, the investment. So X is the amount invested in the A. Its interest rate is 15%. So you multiply X with 15%, that give you the annual interest. Plus, the rest go to the stock B. Its interest is 10%, do you agree? And that's the first equation. So I want to check if you